In today's lesson, we're going to learn about PHP. PHP stands for the PHP Hypertext Preprocessor. It's a recursive acronym. It also stands for Personal Homepage, but nobody acknowledges that anymore. PHP was really developed early on as a set of tools that you could use to build websites. It has a look and feel very similar to Perl that we've already talked about, and you'll see some of the constructs in PHP are very Perlish. There's been through several iterations and several versions, and we're currently on PHP version 5. One of the nice things about PHP is that it's an interpreted language that can be interspersed directly in your HTML. So here's an HTML file, like you'd have for a web page, and in the middle of the normal text where you just have kind of the writing and stuff, there's a block of PHP code that gets interpreted so that all of the commands will be run and the results will be displayed right there in the HTML. The way that you know there's PHP code is that there are delimiters that begin and end the PHP block. They're shown here. A less than sign, a question mark, and then PHP starts the block of PHP, then gets interpreted, and then a question mark and a greater than sign ends the block. Some people leave out the PHP at the beginning of the block, but I think that's bad practice and you should include it at all times. You can also run PHP as a standalone file. Do the same thing. Wrap a block of PHP in the delimiters, and then you can just call it. In fact, for a standalone file, if you're just going to call it with PHP, you don't need the delimiters, and it will get interpreted. Just like a Perl file or a Python file, something like that. PHP is kind of a silent language. If there's no echo or print statement inside of the code, nothing will get output. In this block of PHP that I've shown here, nothing is output, nothing is returned to the browser. You can add comments in PHP code. There's two different ways of doing it. You can add inline comments by using 2 slashes, or you can add block comments. And you can see that those are more in line with the C style of coding rather than the Perl style of coding. However, more like Perl, all of the variables in PHP begin with a $sign. However, all of them begin with a $sign, not just the scalars. Even arrays and other things begin with a $sign. And you can see from these examples that PHP is a loosely typed language. You can reference elements in a list, and you can have hashes as well. Hashes also begin with a $sign, and you can have a name and associated with a value. There are some constants that are built into PHP, like the 3 that are shown here. They begin and end with 2 underscores, and these 3 describe the line number in the file, the directory of the file, and the actual file, the PHP file that's being processed. And you can define your own constants for use in your own code at any point. Almost everything in PHP is locally scoped. You have to explicitly declare something to be globally scoped if you want it outside of any block. And one of the problems with global scoping that you'll need to be careful about is namespace collisions. PHP has a lot of defined variables, and you don't want to overwrite some of those variables with one of your own. You can also scope a variable as being static, but that variable will only be available to that function, but that variable will be available every time that function is called for as long as your code exists. There are some variables that are really important for web programming. The 3 in particular that you'll use the most are get, post, and cookie. When you call a website and you pass in variables from a form or from the URL, those variables are passed as either get or post. There's a subtle difference between the way your browser passes the variables depending on if it's using get or post. However, for most situations, at least beginning on, we'll be using get. Cookies, of course, are variables that are stored on your machine, and every time a website makes a request, it gets the cookies back that it's stored there. In fact, get or post are hashes of key value pairs. The keys and values, at least for get, are passed as part of the URL. And so here's a very simple URL that I made up, which has several different parts. There's the actual URL that directs the browser to the company. There's the name of the file to get, and then there's the block of key value pairs. In fact, in this example, there are two key value pairs, name and age. Name and age are the keys, and Rob and 21 are the values. They would get passed to get as an associative array where the value Rob is associated with the key name. The value 21 is associated with the key age. You can iterate over the items that are returned by your browser using a standard iteration construct for arrays. However, this only iterates over the values and not the keys, and so it's of limited utility when you're iterating over things that are returned by a web browser. But you can use the foreach construct on any array. PHP provides a mechanism for converting between associative arrays and named variables. So the command is called extract. Here's our example URL again, where we have two key value pairs, name and age. If we pass that to the PHP file, and PHP calls extract on $_get, we end up with two variables being created, name and age. So if we know the variables that are passed to our PHP form, we can create variables just using the extract command. To go the other way, from named variables to an array, you use the compact command. That's the opposite of the extract command. But of course there's a problem with extract. If I have a variable that's already defined, like name, and I run extract $_get, I'm going to overwrite my name. So now the value of name becomes Rob and not what it was before. The other problem, the real problem with extract, of course, is that somebody could do something malicious. Somebody can pass in a set of variables to your PHP file that have really weird constructs and could actually break all of your code. The way to get around that is use the optional command to extract, which will give you a prefix on all of your variables. The way that you do this is you provide extract with three parameters. The first one is the variable that you want to extract, in this case $_get, but it can be any of your variables. The second parameter is the command extra prefix all, and then the third parameter that you pass in is whatever you want to prefix all of those variables with. In this case, the value Rob gets assigned to a new variable, and it's called got_name. So the got part comes from the third parameter that you passed to extract, and the name part comes from the URL that was passed into the PHP script. You can see, using this, you can protect all of your variables from being overwritten, and only variables that begin with the word got_ are ones that come from the browser. One thing to note here is that there's an A missing from extra, so it's extr_prefix all. Another very useful function that PHP has built in is the printr function. This prints any variable that you pass it in a human readable form. It makes it very simple for taking a quick look at a variable and trying to understand what kind of variable it is. Is it an associative array, like in this case? Is it a scalar? Is it a normal array? As you're building up a PHP program and you're trying to understand exactly the variables that have been designed so far, the print_r command can be extremely helpful. PHP includes strong support for regular expressions, and there are 3 different functions associated with regular expressions. The first one just matches once, and the alternative matches every occurrence, so like an individual match or a global match. These 2 commands take 3 parameters to the functions. The first one is the regular expression to match. In the top case that matches whitespace, and in the bottom case it matches a tab. The second one is the variable that you want to match to, and the third parameter is a variable that you want to put the matches in. The replace command also takes 3 parameters. It takes the regular expression that you'd like to find, the regular expression you'd like to replace it with, and the name of the variable that you want to run that regular expression upon. Of course, I've only shown some simple examples here, but PHP's regular expression support is built very similar to Perl's, and you can use all of the strong expressions in Perl that you can use in PHP. So we've taken a very cursory look at PHP and some of its constructs, and I really want to dive into using PHP to access MySQL, because that's the strength of PHP. It has really strong support for databases, for accessing databases, and for taking data from databases and making it into web pages. There's 2 common libraries that people use for accessing MySQL from PHP. The first one was MySQL Query, and that's really an old library that is no longer being developed. It's supported, but it's really deprecated. And you shouldn't really use the MySQL libraries like that. The second library is the MySQL-I, which is the more modern library. It has a lot stronger support for things like prepared statements, and is a much more appropriate way and a better way to access MySQL from PHP. And for all of the development that you do, you should use MySQL-I. To access MySQL, you create a new MySQL-I object, and you pass that 4 parameters. You pass it the host, the username, the password associated with that username, and the database that you'd like to use to get your data back. This is a very standard construct where once you've connected to the database, you check and see if there's an error. If there's an error associated with a connection, then you die and you get out of there. You don't want to continue because you're not going to be able to retrieve data from that database. So remember, at the beginning, we were talking about files that don't produce any output. That's kind of a weird behavior. Why would you want to have a file that doesn't print any output whatsoever? One of the places that you'd like to do that is to have a separate file that contains the host, the username, the password, and the database name that you're going to connect to. You can set those into a separate file. You can provide very limited permissions to that file so that only selected people can read them. And then you can contain your passwords away from the actual code that accesses the database. This is a nice security feature that if somebody just calls this code or tries to download that file, they won't get anything. They'll just get an empty file because the PHP gets processed and there's no result returned. So you can put all of that together and have a file which contains the PHP commands, it contains the access information for the database, it connects to the database, and then it reports if there's an error. And the advantage of this is that you can have that as a separate file, and then in subsequent files you just need to access the MySQL variable and use your database. You don't need to worry about connecting to the database, that's already taken care of. And you can have multiple independent PHP files that all read this simple file and connect to the database. So what happens when somebody accesses your password file? Aren't they going to be able to just see your passwords? So here's an example file that I've put online that you can run and see what actually happens. And you can see if you can try and get these passwords. Don't worry, the password in there is not a real password, and you won't be able to access anything with it, so if you're successful, you won't be able to go anywhere. So how do we include one PHP file in another? There's two different commands that we can use. We can require the file, or we can include the file. Requiring is much stronger demand than including. And if you require a file and the file doesn't exist or you can't read it, then everything will break. If you demand that you include a file but the file doesn't exist, then not so many things will break, at least at the point where you include the file. Subsequently, other things will break, of course, because presumably you're including a file for a reason. However, not everything will break. But in reality, you don't actually want to use require or include. You probably want to use require once or include once. The advantage of saying include once is if you have multiple PHP files that you include, and one of those files has already included your file, it won't get read again. For example, if you have a file that accesses the database using the username and password, and then you need to access the database again, if you use include once, then the variable will to access the database connection, and the usernames and passwords will only be read and created once. They won't be read and created every time they're demanded. So this is a time and space saving construct that's good habit to get into. One of the reasons that we need to use the MySQLi interface and not the MySQL query interface is because PHP provides strong support for bind param using placeholders. So the placeholder is a question mark in your SQL statement. If you construct an SQL statement like this, you can then bind a parameter to that statement. The bind param takes two different parameters. The first is the type of variable that you're passing. Remember that PHP is a loosely typed language, and so it doesn't know what types of data you have in what kinds of variables. And then the second parameter that you pass is the actual variable that you want to bind. The types that you can include are integer, double, string, and blob. And if you have multiple variables that you're passing as a bind parameter, you need to include one definition for each variable. In this case, we're passing an integer, two strings, and a double into our SQL query. So why should we use bind param? The two main reasons are that it prevents SQL injection. When you use bindparam, all of those inserts, updates, deletes to your database get appropriately escaped, so you can be sure that nobody is maliciously manipulating your database tables. The second advantage of using bindparam is that all modern databases will use query and execution caching on your particular query. The query and the way the query will be run is cached by the database, so that when you make multiple requests of the data from the database, each time it doesn't have to reconstruct the best way to execute the query, and it doesn't necessarily have to redo the search. It can just cache everything and get it back to you very quickly. Just like bindparam, there's a command called bindResult, which takes a result from the database and connects it to a variable, and you can pass in multiple variables, one for each column that you've been returned. And so here's some PHP that we can use to make SQL queries. We start with our select statement from our database, and we call the mySQL variable that's in our secret file that nobody else can read, and we pass in a prepare statement, select name from student where ID equals question mark. We've got a placeholder there. We bind a parameter to that, an integer in this case. We execute the command. And of course, we always want to check that we're able to execute the command, and if not, then we die and get out of there. We bind the result of the query to a variable. We only have one column in this case, so we only use one variable in our bind result. We fetch the result, and that will actually get the data from the database and put the result into our variable that we've used in the bindResult command. And then we can display the result using echo. Finally, we close our connection so that we don't leave SQL connections open in our program. Here's a longer example, and I'm going to leave it to you to take a look at this example, try and understand what it does, and then write a piece of PHP code using this example to access the database of our student data example that we've seen in previous classes. So we've talked about PHP today. It's a loosely typed language, it's built very much like Perl, and I've just brushed over the surface of the commands that are available. But many of the commands are similar to things that you've already seen in Perl, and I don't want to repeat those. PHP seamlessly integrates not only with MySQL, but also with HTML pages. And it makes it trivial to make web pages that do beautiful things, accessing data from databases and returning that data to end users. The absolute key that I can't stress enough is when you're coding in PHP is to use placeholders. It'll protect your site from SQL injections, and it actually speeds up your searches. So there's two good reasons you should use placeholders.